Welcome to 10.3. We're going to talk about a special case in inequalities. Let's start by trying to solve this inequality first. Negative 4x is less than or equal to 8. Well, I'm multiplying my variable by negative 4, so I'm going to divide by negative 4 on both sides. Simple enough. This is just like yesterday. So we have x is less than or equal to negative 2. 8 divided by negative 4 is negative 2. So let's plot it. It's closed circle. Oops, that should be closed circle. And if I plugged in a value, let's try 0. 0 is less than or equal to negative 2. That's not true, so I'm going to point away. If you get a false statement, you point away. 0 is over here to the right, so I'm going to point to the left. Now let's check something. Is this true? Now at this point, it's a true statement. But does this inequality, does this plotted inequality represent the original inequality we were given? Let's take a point and see if we get a true or false statement. Let's try negative 4. So negative 4, and we'll just replace the variable with parentheses to test anytime you ever need to plug it back in. Negative 4 times negative 4 is less than or equal to 8. Negative 4 times negative 4 is positive 16. Well, is positive 16 less than or equal to 8? No, it's a false statement. 16 is greater than 8. So the inequality that we plotted is not the inequality we started with. This is our special case. If you multiply or divide by a negative number, so not if you multiply or divide a negative number, if you multiply or divide by a negative number only, you must flip the inequality sign. Let's look at an example. So I have negative 3x is less than or equal to 9. What's happening to my variable? I'm multiplying by negative 3, so I'm going to divide by negative 3 on both sides. Well, that canceled. I just divided by a negative. So when I rewrite it, 9 divided by negative 3 is negative 3. My inequality should go in the opposite way. It went from less than or equal to greater than or equal to. This will make it so we actually plot it correctly. You don't need to know why. You don't have to understand any of the details about that. But just understand that if you multiply or divide by a negative while solving, you have to flip your inequality. So it's a closed circle at negative 3. I'm going to test a point. 0 is greater than or equal to negative 3. Well, that's a true statement. 0 is always greater than all negatives. So I'm going to point at the 0, which is to the right. So I'm going to point to the right. X over negative 2 is greater than 5. I'm dividing by negative 2, so to solve it, I'm going to multiply by negative 2 on both sides. Remember, when you multiply or divide by a negative, you end up flipping your inequality. This was greater than, it's going to become less than. So x is now less than negative 10. So I'm going to plot at negative 10. It's going to be open at negative 10. Let's test a point to see which direction I'm going to point at. Let's try 0, because 0 is always easy to work with. Is 0 less than negative 10? That's a false statement. 0 is always greater than all negatives, less than all positives. So that's a false statement. I can't point at 0. I have to point away from 0. Okay, so 0 is to the right. I need to point to the left, the opposite direction. Negative 35 is greater than 5x. What's happening to my variable? I'm multiplying by 5, so I divide by 5. 5 divided by 5 is 1. That's my identity. Negative 35 divided by positive 5 is negative 7. Now, I'm not dividing by a negative. Don't get it confused. Just because you see a negative in the inequality or you're multiplying or dividing against a negative does not mean you're multiplying or dividing by a negative. It's only if this number that you're writing in when you're multiplying or dividing is negative do you flip the inequality. So in this case, my inequality stays the same. Negative 7 is greater than x still. So I'm going to plot at negative 7. Let's open at negative 7. I'm going to test a point. I'll test 0 because it's always the best way to go. Negative 7 is greater than 0. Is that true? No. Negatives are always less than 0. 0 always has to be bigger than negative 7. Or sorry, any negative I should say. So therefore, I can't point at 0 to the right. I have to point to the left, the opposite direction if I get a false statement. On your own, try these U-Try problems. Remember, show all of your work in order to receive all of your credit. Pause the video and come back when you're ready. Welcome back. When we solve this one, we should end up with x is less than 3. You had to flip the inequality because you divided by negative 4. I'm plotting at positive 3. And it's pointing to the left. Again, check a point. 0 is less than 3, so that's a true statement. When you solve this one, you should end up with negative 6 is less than or equal to x. Again, because you had to divide by negative 2 at one point, you ended up with a flipped inequality. Less than or equal to. When start is greater than or equal to, we end with less than or equal to. I'm going to go to negative 6, plot a filled in circle, check a point. 0, for example, always works best. Negative 6 is less than 0, so I'm going to point at my 0. 0 is to the right, so I point to the right. We just elaborated on solving one-step and two-step inequalities. Go ahead and rate your understanding or how well we hit our target on a scale of 1 to 5. If we did not hit a 5, please make sure you ask questions tomorrow in class. Thanks for stopping by, and I'll see you in class.